Math Conquerors, and welcome to our lesson today, 8-7, where we will be exploring more about the quadratic equations and how to factor them. We're going to review ax squared plus bx plus c equals 0, but in this lesson, a is not going to be equal to 1. So far in front of our x squared, we have not had any number except 1. Today you're going to find numbers in front of these x squares that are not 1s. So we're going to apply a new principle, which is ax squared plus mx plus px plus c equals 0, where a is not equal to 1. So let's apply this and let's talk about this. This is on page 510 in your book. 2x squared plus 5x plus 3 can be rewritten as 2x squared plus mx plus px plus 3. Now our new method that we're going to be using to factor is we're going to multiply the 2 times the 3. The number in front of the a and the c. So we're going to multiply 2 times 3, and we're going to ask ourselves, what are two numbers that when I multiply them together, I get 6, but when I add them, I get 5? Well, I know that the factors of 6 are 1 and 6, which equals 7, and 2 and 3, which equals 5. So I'm going to use 2 and 3. Now, the important part of determining who is m and who is p is we want to group things together that can be factored, that we can get a greatest common factor. So I know if I put the 2 over here with the 2, that's going to make a little bit more sense. So I'm going to say 2x squared plus, now instead of mx, I'm going to put 2x, and I decided to put that with that because it looks nice with that, plus, now instead of px, I'm going to use 3x plus 3. Now, just suppose I had put the 2 here. Well, I can't factor anything out of that. I need to factor common factors, the greatest common factor out of these. So what is the greatest common factor I can get out of 2x squared and 2x? Well, I can take out a 2x. So if I take out a 2x, that leaves me with x plus 1. Here, I could take a 3. And if I factor out a 3, I have x plus 1. Now remember, I positioned them so that I could factor them. Then all I have to do is put this together. I have 2x and a plus 3. So I say 2x plus 3. And then notice I have an x plus 1 and an x plus 1. Those are common factors. I don't write it 2 times. It's simply x plus 1. If you work the full method for 2x plus 3 times x plus 1, you will get this quadratic equation. Okay, our next problem is on page 511, and it is 7x squared plus 29x plus 4. First thing we're going to do is multiply a times our b, which is going to give us 28. I need factors of 28 that when I add them together, I get 29, which of course is 1 and 28. So that's what I'm going to use. Now again, I want to group them so that I can get the greatest common factor. So I'm going to choose to say 7x squared plus, instead of mx, I'm going to put in 1x plus, instead of px, I'm going to put 28x plus 4. Okay, I can see here that I can factor out an x, leaving me with 7x plus 1. Here, what is the greatest common factor of 4 and 28? That would be a 4, leaving me with 7x plus 1. And again, that is my goal, is to get common factors. Here I have a common factor, 7x plus 1, 7x plus 1. Now I can just rewrite the problem. I have an x plus 4. So I would write x plus 4 times 7x plus 1. Again, if you use the FOIL method to multiply this back out, you will get the quadratic equation 7x squared plus 29x plus 4. Okay, now we're going to work 1A on the guided practice on page 511, and it is 5x squared plus 13x plus 6. Again, we're going to multiply A and C, so 5 times 6 equals 30. So I need two numbers. When I multiply them, I get 30. When I add them, I get 13. So first thing that comes to my mind is 10 and 3. Now when I'm looking at this problem, I know if I put the 10 with the 5, I could factor out 5s. Put the 3 with the 6, I can factor out 3. So you always want to look for common factors, things that you can factor out of the problem. So I'm going to rewrite this as 5x squared plus 10x plus 3x plus 6. Okay, make sure you're putting it in the right formula. I could take out a 5x here, leaving me with x plus 2. I can factor out a 3 here, leaving me with x plus 2. And again, this is what we are looking for. We want to find common. So when I put this together, I'm going to have 5x plus 3 times x plus 2. Again, if you use the FOIL method, it will take you back to our original quadratic equation. Okay, this is number 1B on our guided practice. Now, so far, we have not factored anything out before we began our problem. But we always want to reduce our problem down as low as we can because it's easier to work with. So the first thing that I see is these are all multiples of 2. So why don't I take out the 2, and that would make my problem, my numbers, easier to deal with, leaving me with 3x squared plus 11x minus 4. There's no reason that I can't do that. 6 times 8 is 48, but it's a whole lot easier to work with 3 times 4. And 3 times 4 is 12, so I'm thinking of factors of 12 that when I add them together, or I subtract them, I get 11. And of course that would be 12 and 1, with the 1 being negative. Okay, I'm going to put the 12 with the 3 because I know that I could factor out a 3. So I'm going to say 3 times 3x plus 12x minus x minus 4. Now, I could put me some brackets here to kind of help with what's going on. There we go. And so now I need to factor out 3x, which would leave me with x plus 4. And over here I want to factor out a negative 1, which would leave me x plus 4. And now all I have to do is put this together. So let's look. We have an extra thing to put, and we just need the 2 outside of everything. It just needs to be distributed back in. But here is my common. Okay. So I'm going to write this as 2 times 3x minus 1 times x plus 4. And so all I would have to do is work the full method and then multiply or distribute my 2 back in, and I would get the original equation.